And then on the right-hand side of your screen, you can see the engine nozzle of that Merlin vacuum engine on the second stage. That is currently accelerating the Dragon spacecraft to match orbit with the International Space Station for its eventual berthing maneuvers.
It's an interesting semantic point that the process of connecting the Dragon to the space station is called berthing with an E. And that's because it is brought to the space station by the Canaveral, while docking actually refers specifically to two spacecraft that can connect without any external assistance. This stems from old shipping days in which ships would come into the harbor and dock themselves under their own power, while larger ships, which aren't able to easily navigate in harbors, are met by tugboats and then berthed. So for the space station, the robotic Canaveral is like a tugboat for the Dragon spacecraft.
That Dragon spacecraft will make its way to orbit after it separates from the top of the second stage, coming up later in the mission. But right now we are focused on both that second stage still accelerating and the first stage coming back down for a landing. Next step up for the first stage is going to be a reentry burn. That's when it's going to light 3 of its Merlin engines to slow itself down as it hits the denser regions of the atmosphere. You can actually see on the left-hand side of your screen, that is Cape Canaveral and the coastline of Florida. You can see that first stage is oriented towards Cape Canaveral and currently about to decelerate. That reentry burn will be happening in 30 seconds. In addition to those reentry burns, you actually saw some what looked like frozen condensation floating off the side of the first stage. In addition to those burns, the first stage also uses those titanium grid fins to control itself and cold gas thrusters, which are those bursts of air you can see periodically issuing from that first stage. Let's watch the reentry burn happen in about 5 seconds.
Stage 1 entry burn startup.
You can see all three of the 9 of those Merlin engines light up right now, executing that re-entry burn and slowing that first stage down.
Stage 1 entry burn shutdown.
And we just heard the call out for an entry burn shutdown. Landing burn will begin. That's the next phase of landing at T plus 7 minutes and 35 seconds. We currently have an unbelievable view of Cape Canaveral from the bird's eye view.
It is absolutely amazing. I've been at Cape Canaveral for these landings before where you can feel those sonic booms in your chest. It is just so exciting along the Space Coast.
Stage 1 transonic. Stage 1 landing burn startup.
Stage 2 continues along the nominal trajectory.
Right now, stage 2 is currently on a nominal trajectory. This is the primary mission to get that Dragon spacecraft into orbit. Right now you can see that second stage engine is performing nominally with the Merlin vacuum engine glowing red hot.
Flight operators need to return out to a site rep and we can continue to super what
You may have heard the SpaceX team cheering in the background. It appears that the stage 1 of the Falcon 9 has made a water landing off the coast of Cape Canaveral. Still waiting on exact word for what happened there. Just a quick reminder, the primary mission today is to bring the Dragon to the International Space Station. Right now that mission is going spectacularly. All telemetry from stage 2 looks nominal, and it looks like we are approaching a good orbit. Waiting for confirmation on that soon.
Now the Dragon spacecraft is set to arrive at the International Space Station in just a few days, where our astronauts will be conducting that groundbreaking research that it is carrying up.
And right now we did have confirmation of a good orbit from that second stage with the Dragon. Right now the next phase of the mission is going to be Dragon separation from the top of the second stage. We'll be able to see, you can actually see on your right-hand side of your screen, that's a view inside the trunk, the unpressurized cargo section of the Dragon. And I believe you can actually see some of the science experiments that are in the trunk right there.
It's an exciting capability for the Dragon trunk to be able to store unpressurized cargo and take that up to the International Space Station. It's a very unique capability.
And there it is. You can see the successful separation of that Dragon spacecraft from the top of the second stage. The trunk is open to the bottom. It's an unpressurized spacecraft, and I believe those are the two science experiments we're currently going to be mounted on the outside of the International Space Station. But yeah, so the next, Dragon still has a long way to go. The next phase of its mission is going to be extending the solar arrays. So you can actually see on your screen there's two kind of bumps on the side of that trunk. Those are the folded up solar arrays, and in I believe at 12 minutes and 30 seconds, those solar arrays are going to extend and unfurl so that the Dragon can start harvesting solar power and make its way the rest of the way to the International Space Station.
Now, as you mentioned earlier, we've got some cargo inside the trunk of that spacecraft, which you could see as it was pulling away. We have two different experiments. The first one is the JEDI spacecraft, and that's JEDI with a G. It stands for the Global Ecosystem Dynamics Investigation. The JEDI spacecraft will actually measure and create 3D maps of Earth's tropical and temperate forests. These measurements will help scientists determine how much carbon is stored in the world's forests. Also inside Dragon's trunk is the Robotic Refueling Mission 3, known as RRM-3. The investigation will demonstrate technologies to store and transfer liquid methane, a type of cryogenic liquid, in space for the first time. That will help NASA develop capabilities to service and refuel spacecraft in orbit set for long-duration space flights.
And obviously, we here at SpaceX have an interest in long-term duration space flights for our eventual plans to send humans to Mars. So all of this research helps us, and we're excited to help NASA bringing that research up to the International Space Station. Like I was saying earlier, we are currently waiting for the Dragon solar array deploy coming up in about 30 seconds, 30 or 45 seconds. Those solar panels are covered by shrouds on the side, carbon fiber shrouds. And so we might be able to get some video, hopefully, of those shrouds popping off and those solar arrays extending. Shortly after the solar array deploy, we won't see this, but the next step for Dragon is to open its GNC bay door. That stands for Guidance, Navigation, and Control Door. It's sort of like Dragon opening its eyes, exposing its sensors to space so it can find and lock onto the station and make its way the rest of the way towards the ISS's orbit. And as you can see right there, that is a confirmation of Dragon's solar panels deploying from the side of that trunk. This is excellent news. It means that Dragon is now able to power itself all the way the rest of the way to the space station.
Dragon is now on its way to the space station. When Dragon arrives in just a couple of days, the spacecraft and the space station will establish a direct communications link, and then Dragon will slowly approach, pausing at several checkpoints to ensure that everything is still going as expected. Eventually, as Dragon approaches closer and closer, the European Space Agency astronaut Alexander Gerst will reach out and capture the Dragon. Next, ground commands will be sent to Mission Control, or from Mission Control in Houston, for the space station's robotic arm to reach out, rotate, and install it on the bottom of the space station's Harmony module.
Well, 13 and a half minutes since liftoff when that entire rocket was at Cape Canaveral. We had some great views. The weather cooperated today. The ground winds weren't too high. We were able to launch right out the opening of the window. You saw ascent, great stage separation. We did get some great views of the first stage and the grid fins coming back, but as you heard from some of the background noise and comments, the first stage did land in the water. Now the good news is we've got a lot of telemetry from it, so we'll be able to understand what happened and work to improve reliability as we always do here at SpaceX. Second stage went into great orbit. It was really precise. Dragon you saw separate, and now the solar rays coming out. All told, another great day for SpaceX and NASA.
Dragon's arrival, capture, and installation to the International Space Station will be streamed live on Saturday, December 8th on NASA TV and on SpaceX.com/webcast. Dragon will spend about 5 weeks attached to the space station before returning to Earth with cargo and research.
Please follow NASA and SpaceX on our social media pages for ongoing updates. I personally will be covering that early morning grapple and capture, so please tune in for that on Saturday morning. And please, thank you to NASA, the range, the FAA, and you, the viewer, for tuning in. We greatly appreciate your support for these launches. Until next time.
You